everybody. Today is Wednesday and this instructional video is for Thursday. All right, so what we're going to be talking about is heat transfer. And if you see in the middle, I have our learning objective. We haven't had our learning objective in a while because we've been reviewing, but our learning objective is I will be able to analyze and explain how heat transfers through different objects. All right, so let's go ahead and get started. All right, so before we get started, I want us to think about what is the difference between transfer and transform. So I want you to pause this video and think about what is the difference between transfer and transform. All right, so to transfer, remember when I talked about transferring and transform when we first started talking about energy? I talked about transfer if I asked my mom, my sweet mom, to transfer money into my bank account. So if I'm asking my mom to transfer money into my bank account, she's simply just shifting it or passing it on. She's passing the money from her bank account into my bank account. She's shifting the location of where that money is. It's no longer in her bank account, it's in mine. To transform means to physically change in the form. So to physically change the form. So if we think about transformers, they are first cars, and then they can transform into this tall robot that saves the day. Sometimes destroys the day, but hey, depends on which side you're on. All right, so to transfer is to shift or pass on. So we see our volleyball girl here. She's transferring the ball. She's serving it up. My volleyball girls, you know who you are. She's transferring it. She serves that ball and then she transfers it to the other team. She's simply just shifting the location. She's passing that ball from her hand on her team to the other team. All right. Whereas to transform, we have our sweet little tadpole, and it starts as a tadpole, and you can see that it starts to transform into a frog. So we know that that change is called what? What do butterflies and frogs do? What is the scientific term? Metamorphosis. Good job. So we can see that that frog is transforming from a tadpole into a frog. So remember, transfer is to simply shift or pass on. Transform is to physically change in form. So we are going to talk about how heat transfers, how heat can pass on, how it can be shifted from one object to the next. So let's go ahead and get started. All right, so before we even do that, I want you to look, I pointed to my ears, I want you to look and listen to the Brain Pop video heat transfer. So I've already assigned it to you guys into Schoology. So if you watched the instructional video from Tuesday, I showed you guys how to access Brain Pop through Schoology. So if you look right in here on the left-hand side, in your Schoology folder on the left-hand side, you'll see Brain Pop. You're going to click on that, and then up at the top you'll see a little bell, and you'll see where I've already assigned you guys some videos and some assignments. I want you to go ahead, and for this video I want you to watch the heat transfer video, and I want you to just look and listen as they talk about heat transfer. Okay, so I want you to pause this video, go watch the heat transfer video, and then come back. All right. Okay, so now that we are back, you've watched the Brain Pop heat transfer video. We're going to talk about how heat transfer happens. So it happens when warm particles move from warm to cool. So those warm particles are moving from warm to cool. All right, so we see here is our picture of heat transfer. We see that there's a word that says convection, there's a word that says conduction, and there's a word that says radiation. And we see that there are three little scenarios. Okay, so I just want you to look and see, what do you notice? What is the difference between all of those situations? All right, so there are three ways heat can transfer. There are three ways heat can move. The first one is conduction. The second one is convection. The third one is radiation. So they are all right here. All right, we are going to go a little bit more in depth, but we see conduction is happening. He is holding it and he is placing it over the fire. We see that convection, he has his hands over the fire, and that radiation, his hands are near the fire. All right, so let's break them down and let's talk about them separately. First, I know if you don't know, Miss Brown loves a good cheeseburger. She loves a good cheeseburger. So I want you to look at this picture of this cheeseburger and think, how is heat being transferred? How is heat shifting or being passed on through a hamburger? All right. So we have conduction. We talked about conduction on the previous slide. I mentioned conduction on the previous slide. So conduction is the transfer of thermal energy, which is heat energy. It's the same thing, through direct contact. Conduction transfers through direct contact. So I'm going to circle that. And in your notes, I want you to write conduction, direct contact. So where in our picture, and if we're looking at this hamburger, where is that heat being transferred through direct contact? Where can we see heat being transferred through direct contact? Let's think about it. When I put my, we're about to make our burger. So I put my bun down and then I put my burger down. And then when I put my cheese down, what starts to happen to the cheese? It starts to melt, and it's melting because of conduction. Our burger, when we take it right off the grill, that heat is still in that burger, and when that cheese gets on that burger, it's coming in direct contact with the heat source, which is the burger, and it's starting to melt. All right, I also have another example. A good old slab of butter, the more better, the more butter, the more better. All right, so that butter is on the stove, and as soon as they place it in that hot skillet, it starts to melt. It's coming in direct contact with the heat source. And we know that it's happening because that butter is starting to melt. So that heat is going from that pan to that stick of butter, because on the previous slide we said heat always travels from warm to cool. So that heat is being transferred from that hot skillet to that cool butter through conduction, that direct contact. All right, so conduction equals direct touch. Heat being transferred through direct touch. Heat being transferred through direct touch. Next, we have convection. I want you to look at this picture. What are some things you notice about the picture? What are some things you notice about our picture for convection? So we have the arrows, we have our warm molecules going up and our cool molecules going down. We have a little circle arrows that's going around. Also, where is this taking place? Where is this taking place? It's not on a burger. This isn't a picture of a burger. This is a picture of a pot of water. So convection happens. It's the transfer of thermal heat, thermal energy, by moving through liquids and gases. That makes sense because our picture is a pot of water. It's a picture of a pot of liquid. So it's the transfer of thermal energy by moving through liquids and gases. The important part about convection is that we need to know that warm air rises and cool air sinks. A way I remember this, so growing up, we had a 3-story home and it was always really, really cool on that bottom level. But when we went all the way up to the top, it was always so hot. But that's because of convection. That warm air rises because it rises and that cool air sinks. So warm air rises, cool air sinks, and we can see that in our arrows. So that warm air is rising and that cool air is sinking. So I want everyone to draw. We're going to draw our arrows. Actually, I'm going to, So I have my red for warm, and then I'm going to change it to blue, that cool air sinking. All right, if you don't have colored pencils or markers, that's totally okay. We're going to label it. Cool air is sinking, warm air is rising. All right, so those warm air molecules are rising, those cool air molecules are sinking. All right, so then we see, and we have our little toaster oven. We have our toaster oven and we have our piece of chicken in the toaster oven, and that warm air, I'm going to erase it so you can see it. That warm air is rising and that cool air is sinking. We can see that that air is circulating. That air is circulating. So I want you guys to write this down. Convection equals circulate. Circulates means, what do you think circulate means? It moves in a circle. Yep, it's moving in a circle. So that warm air rising, that cool air sinking. Warm air rising, cool air sinking. Let's do it all together one time. Warm air rising, cool air sinking. All right, so conduction, direct contact, convection, circulates, and last but not least, radiation. So I need to make it very clear that Miss Brown is very afraid of cats. But my man right here is straight chilling. So I had to include this gift, okay? But what do we notice? How is he being transferred? Why is he just sitting by the window, sprawled out? So last but not least, we have heat being transferred through radiation. When you hear radiation, what other type of words do you hear? Okay, radiate. And radiate means waves. Radiate reminds me of waves. So radiation is the transfer of thermal energy through space without particles. So that means it's without conduction, it's without that direct contact, without particles colliding. That colliding means they're coming together, it's not touching, and it's not moving to transfer. So that energy, that heat energy isn't being transferred. It's not becoming, that warm air isn't rising, that cool air isn't sinking. So it's not being transferred through conduction or convection. It's simply just being passed on, it's being absorbed. So the cat is experiencing heat transfer through radiation, through waves. So as it's sitting by the sun, it's getting warmer. All right, another way we can think of radiation is the earth gets warm through radiation from from the sun. So that those heat waves radiate to the earth and warms the earth. All right. So radiation warms an object when it's being absorbed. Another way to think of radiation is if I put my hands by the fire or by the stove, that heat is being transferred through radiation. I'm not directly touching it. That warm air isn't rising and that cool air isn't sinking. I'm simply, it's kind of just like, just here you go, man. I'm gonna just pass you a little bit, but it's just so nonchalant. It's just you're in the area, so you're gonna feel the heat. You're not touching it, and like I said, that warm air and cool air isn't rising. It's just that you're in the area of that heat, and it's just being passed on. You're absorbing it. All right. So I will give some examples in a few slides ahead, but remember, heat always transfers from high temperatures to low temperatures. And the hotter the temperature, the faster the particles move. The hotter the temperature, the faster the particles move, okay? So, hold up. I'm going a little too ahead of myself. We cannot forget to talk about insulators and conductors. So remember we talked about insulators and conductors when we talked about electrical energy. Those conductors were wires. It allowed that electrical energy to flow through. That was good. That's what we wanted. And the insulators didn't. And that's also good. We didn't want the electrical energy to flow through the insulators. Why? Because we would be getting shocked. So if I was touching my laptop charger right now, you guys can't see it, but I'm touching my laptop charger right now, but I'm not getting shocked or zapped by that electrical energy because there is insulation on the outside. I'm touching the insulation, which is that little rubber coating. Okay, so we're going to talk about heat insulators and conductors. So insulators don't allow heat and electrical energy to flow through. It kind of slows it down. Whereas conductors allow that thermal energy to flow through. So if we look at our picture, we can see that it says conductors allow energy to pass through. They're the truckers, and insulators, they either stop or slow that energy down. They're the haters. So I want us to look at the picture and I want us to note, what do you notice? What are some things you notice about the picture and about what items are in conductors and what items are in insulators, what items are in electrical and thermal? So let's look at it. So we see that metals are good electrical conductors and thermal conductors. So if we think about it, that's true because a lot of electrical conductors are those wires, and a lot of thermal conductors are our metal pans, the pans that we cook with. However, another thermal conductor is a glass. But where is glass for electrical? Glass is an electrical insulator. Okay, so glass is a thermal conductor. Glass holds on to heat. So when you cook, if I were to put my glass pan into the oven, I would not be able to touch it because it's allowing that heat energy to pass through. So it's coming directly from the glass to me. All right. Insulators, thermal insulators, it holds on to that heat. It kind of slows it down. So if we think about insulation in our homes, we have insulation in our homes and it stops or slows down that thermal energy from passing through, which is a good thing because we don't want that thermal energy just to pass directly through our house. Then our house would always be cold. We don't want that thermal energy to just pass through our coats because then we would always be cold. So thermal insulators slow that thermal energy down and it kind of just holds it. So blubber fat is a good thermal insulator, especially for polar bears that live in the really, really cold weather. All right, so let's remember conduction is that direct contact. An example of conduction is a nice slab of butter melting in a hot skillet pan. Convection is that circulation, so that warm air rising and that cool air sinking. And let's think about if you're baking, a way you can tell is if your cake is done, if you can poke a hole. Because from the outside looking in, my top is warm. My top is done. But when I poke my hole, when I go down to the bottom and I take it out, it's still wet. It's still cold. That warm air is rising and it's causing my top to be done, but that cool air is sinking, which means my bottom is not done. Okay? So remember, convection circulates, warm air rises, cool air sinks. Radiation is those heat waves. Heat being transferred through heat waves. So an example would be warming our hands over a fire, or if you go to like a buffet and you can see there's like a heat lamp over the food, it's keeping it warm and that heat is being transferred through radiation. All right, so if I went too fast, as always, feel free to go back and rewind. If you have any questions, do not hesitate to reach out, and I look forward to seeing you guys in class tomorrow. Bye.